Okay, so I'm going to start with a story. Once upon a time, or to be precise, Sunday, 29th of June at 9:15 in the morning. That time when most people are sort of asleep or just chilling or reading their phone or whatever it might be. I stupidly, or maybe not stupidly, checked my work email. And it wasn't as good as I was expecting. So I set up, as all good AWS consultants will, a budget report that sends me a daily update. I appreciate people probably can't see that there, but let me just show you all the figure that I saw. And it was halfway through the month, so I wasn't expecting that number to be quite as high as it was either. So then I looked into the cost anomaly daily summary, because again, it's great practice to do that. And okay, there we ended up with a max daily impact of $500. And that was, by the way, for step functions. So I should say at this point, we were running a bunch of services, and this was a developer we were working with, reasonably new to AWS. They're experimenting. So we put a whole bunch of guardrails around it, limited the number of instances they could turn on, that sort of thing. So it turns out step function's not quite that same. Anyway, by this stage, I am slightly nervous because we had credits for this, and those credits were now exceeded quite significantly. So I went to the step functions console, and I saw this. I point you to this number here. 104, or what's that, 10 million, no, 104 million, 520, well, 10 million, something like that. It's a big number. The day, or when I last looked at that, there were 5. All failed. I'm not too happy about that. CloudWatch metrics, also probably higher than I was expecting them to be. Okay. So in this case, it's shut them all down. I don't care. Turn it off. We'll worry about it later. And by the way, throughout this presentation, I'm going to make some call out. I think there's a couple of people from AWS in the room. This is feedback you can put in using PFRs or whatever you want. Feature requests, please find a way to disable step functions. There isn't. You can delete them, but you can't just disable them. So the only way you can do it is turn it off. So I made a copy of it and deleted it. Right, so I think I've solved the problem. Now it's a case of figuring out, my Sunday morning's ruined by now, so I might as well look at this. What went wrong? So anyone here use step functions? A couple, right. So the pressure's on yourselves then. This is a step function, really simple one. It was set up as a demo. Anyone want to shout out what's wrong with that step function? Any volunteers? People are... Oh, it works. That's the problem. It works all too well. Okay, so the first actual step function. Now, the person who developed this was new to step functions. They saw the big list of actions down the left-hand side, and they thought, oh, start execution. That seems like a good first block to put in. No, the start execution is the top one. This one kicks off another step function. Can you see the name of the step function they're starting? They started itself, and then went through the rest of the process. Can you spot the problem now? It's recursive, exactly. To infinity. Well, not quite to infinity. So second feature request. Can we have a mechanism to at least prevent or identify potential recursive loops? If you put a step function start execution into a step function and it calls itself, there should be a little warning that says, are you really sure you want to do this? Learn from Lambda. So Lambda have had it for a while now, and this has been a savior. Again, I was an AWS solution architect for 8 years. I probably had at least half a dozen times where I've seen developers do this. It's possible to contact AWS support and ask for a refund. This is one of the reasons they give it, if you ask really nicely and promise not to do it again. So you didn't hear that from me. And if you could edit that from the video, Dave, that'd be great. Okay, so it's there, but let's see what you can do. Okay, so now we figured out what the problem is. What are we going to do about it? So, I mean, first of all, I want to see is, well, did I miss something? Because this had been running for a while now, and I'd only got the message on Sunday morning. So I had to look through. Everything was set up. It was recurring budget. It was fixed. I set alerts on it, daily frequency. OK, that all seems fine. But by the way, another feature request, email budget. To set up an email budget report is a ClickOps thing. You can't API it, which is annoying. So say no to ClickOps. Cost anomaly. So again, when to check that, I had it set up. I wanted an alert when I reached 10% over a normal thing or $20 over a normal thing. I think everyone will agree that counts as, that should have triggered, but it didn't. Oh, and by the way, has anyone tried to configure notifications in the console recently?
Yeah.
What do you think of it?
Horrible.
Horrible. I mean, it is hideous. I guarantee that nobody at AWS who works on the system has ever actually done it outside of the US, because trying to get SNS working with end user messaging and user notifications and with Q, which was formerly AWS chat, it's horrible. So smoke signals might be better. So let's try and fix that, please, AWS. But anyway, coming back, why no alerts? Well, so this is an article in the Cost Explorer documentation. I've highlighted the key bit there. Cost Explorer updates your cost data at least once every 24 hours. Okay. It should also be noted that that Cost Explorer data is used for a whole bunch of other stuff as well, like budget reports and anomaly detection. So they're really not kidding. So this is a graph of our cost based on an hourly cost, and I'll talk a bit about that later. So it started at about 11 a.m., 12 midday on the Friday morning. It went through here. I got the alert at that red line. Well, so no, that's when the first alert was sent out at that red line. I actually found out about it at the end of the graph when I picked up my email, because I didn't read my email at 3 a.m. on a Sunday morning. So why a 39-hour delay before that first alert? Oh, and by the way, I should point out as well, the last amount of cost I had here was about, 4 p.m., something like that, on the day before. So I didn't even have any up-to-date metrics that Sunday morning. So again, double-checked, and then I went back through previous days. Everything was they were over budget a little bit, but that was expected. They'd been developing, they'd gone beyond what was expected. That was fine. I went back to check the emails on the Saturday, so the one was sent Saturday morning. So bear in mind, at this point, it'd been running for about 14, 15 hours already as a problem. That didn't show anything. Again, max impact, 44 cents. I can live with that. So why is this? Okay, so I just sort of call out here. The budget summary was sent on Friday, was sent 1 a.m. Saturday, didn't show any issues. The anomaly summary for Friday was sent 3 a.m. Saturday, didn't show any issues. There's about a 16-hour lag between the Cost Explorer data, which is also budgets, cost and usage reporting, anomaly detection, and so on. So another feature request, and this one has been asked for since the dawn of time, increase the refresh rate for budgets. Now, this is a really complex task. Unless you've worked at AWS, appreciating the pure scale of capturing literally billions and billions of metrics on an hourly basis from all the different services to work out the billing report is a massive issue. I get that. But can we have maybe just a really inaccurate bill? I'm happy within 10% that I get every hour. So I can see if suddenly something spikes. I don't care if it's accurate. I just want to know if it's an order of magnitude wrong. So that would be a really nice ask. Anyway, just to summarize, by the numbers. The event lasted for 45 hours from when it started to when I fixed it. There were a total of about 18.5 million state executions, so about 110 per second. There are 131 million state transitions, so about 800 per second. That was bad, but it could have been worse. In London, the default limit for state transition is throttled at 800 per second. In Ireland, it was 5,000. I'm really glad I wasn't running that in Ireland, because that would have been six times the cost. As it happens, though, it still costs more than £3,000 for that step function. Bear in mind, the step function was doing nothing, except, by the way, triggering a Lambda function. So 6 million of those were successfully triggered, which was about 40 per second, plus another 50 million that were throttled but still count as invocations. It used about 57 gigabytes per second of memory usage, which is how it's billed. So the Lambda bill was 114 quid. I can live with that, for the mistake. 75 gig of cloud trail data was logged, which is another 56 quid. Worse, 50 million cloud trail events were logged because, I'm a good person. I turn on all the security stuff that AWS asks us to make money from. Asks us to secure our accounts with. So 50.
You like to be a fly on the wall.
I have been. So 50 million cloud trail events analyzed by guard duty. So the guard duty bill alone was 224 quid. So the total cost of the incident was over £3,500. It's going to hurt a bit. Okay, so that's the story. So that's why I got even interested. And I've been working on FinOps and stuff since probably 2016 when I first joined AWS. Quick question, who in the room here considers themselves FinOps? Okay, wrong answer. If you develop or run on AWS, if you build in the cloud, not just AWS, if you build in the cloud, you are all FinOps practitioners. Because what you do in cloud, whenever you do something in cloud, unless you purely operate within the free tier, it costs you money. So your architectural decisions have a financial implication. It's not like running on-prem where somebody buys a server, it then sits there and depreciates for 5 years, and then whatever you do on it, the worst you can get is throttled, and there's no additional cost. On AWS, we had this concept of don't fear constraints and the ability to scale infinitely. You can scale infinitely, absolutely, but your costs do as well. So just a tiny bit about me. So I've already mentioned this. I'm CEO of Rayo. I used to be CTO of Rayo. I used to be chief technologist at AWS. You can tell how long I've worked at a company by the number of different logo changes it's gone through. So EduServe, I was there 16 years. There was about 3-4 different logos. Amazon, I was there for 2 logo changes, and so far just the one for Rayo. But I've been using AWS since 2011. At the time, I ran a private cloud service with EduServe, and we were experimenting with cloud to prove that it wasn't what it was cracked up to be. Then we had a DDoS attack that took down our entire infrastructure, and we put AWS in front of it as a reverse proxy, and it solved everything, and I became a convert. So I've been pro certified since 2015. I've got my renewal next month. I'm really not looking forward to it. And I've been using it for a while. So it's been a while. And got involved in some really interesting projects in AWS over the years, including with the Ukraine invasion. Okay, so that's me. Back to the story. At this stage, I feel we need to talk about AI. Okay, right, good. Now, next, we've got that out of the way. So how can we control cost? Okay, so let's look at what triggers cost in AWS. There are 2 things, ultimately, you can boil it down to. There's control plane requests. So these are when you make a deliberate action to an API to do something within AWS. So, for example, you can make an EC2 run instances call. You launch an instance. You can create a hosted zone, which costs you 50 cents per month. It might be a system-triggered API request, like an EC2 auto-scaling event. You're not making that request, but you configured auto-scaling, and then AWS is making that control plane request on your behalf. And those are logged in CloudTrail as a management event. You can see what happens. But, then you have data plane activity. And this is a lot harder to sort of budget for and track. So these are things like when somebody does a Route 53 DNS lookup, you get charged per million lookups. You have no control over that. They either look you up or they don't. When somebody transfers something from your S3 bucket, if they transfer it 10 times, you pay 10 times the amount of data transfer outbound. In some cases, you can log it in CloudTrail or in S3 bucket logs or as CloudWatch metrics, but it's not always logged in. It's certainly not logged as a management event in CloudTrail. The key thing, though, is that control plane API requests can be restricted by preventative controls. Not always easy, but you can restrict it. So I can put something in a policy that says deny EC2 run instances, and then I can stop anyone incurring that cost. Actually, though, data plane activity is really difficult. As far as I'm aware, someone can correct me if they can. There are very few services that can be restricted by preventative controls. The one example I can think of that AWS has done recently is CloudFront. They've introduced a bunch of tiered plans, one of which is you pay a certain amount per month, and then if you exceed that, something happens which isn't overly clear, but in theory you don't get billed for it unless you really exceed it, and then they'll probably phone you up and message you and say, look, you need to change this. But it's really difficult to actually design data plane activity to restrict costs. So that leads us to something that I've talked about for a while as cost-conscious design. Has anyone come across this? No. So a couple of nods. So if you haven't, this is why I said at the front, up front that as architects, as engineers, as developers, you should be thinking about cost-conscious design because the decisions you make have a direct impact on the bill. And if we look at why, let's look at constraining costs. So servers versus serverless. If you have a server-based architecture, whether it's on-prem or even in AWS to some extent, it's typically built within a budget. If I'm running a M4 large, I know how much that costs per month. The costs are mostly fixed. I mean, even if I know it's going to scale to 3 during office hours and then scale back down to 1, whatever it might be, I can work that out. Now, performance might be variable based on how far I've scaled that. So if I only allowed to scale to 3 and I get 10x the number of requests, I get throttling. But what I don't get is additional charges. If I implement the same thing as serverless, well, serverless, and again, definitions have changed. It used to be that serverless scales to 0. AWS have backed away from that statement now. But in essence, serverless scales with demand. As you use more, you pay more. So you can almost flip the two. So costs are fixed, performance is variable for server-based architectures. For serverless, you have performance being fixed because it will perform the same because it scales automatically, but your costs are variable and potentially unbounded, as we saw with step functions. I mean, they are ultimately bounded, but that's by the throttling limits on the AWS accounts. That can be pretty high. So the problem with unbounded costs, so traditional infrastructure has those built-in safeguards, like I mentioned. If you try to run too many concurrent workloads, they might slow down, they might fail, they might time out, you might get a bad user experience, but it doesn't really change the overall cost of the service. Whereas serverless definitely has that apparent infinity of scale of cloud. So you run 1,000 queries in parallel, it performs exactly the same as if you ran one query, except 1,000 times as much cost. So how do you prevent runaway? Well, we've already discovered step functions doesn't really give you that limit. Lambda does to some extent, but you need to think about building this into your application. And this is a big concern. I work predominantly in public sector. Again, a lot of commercial developers think, well, if I'm getting 10x the traffic, I'm probably bringing in 10x the revenue, so all's good. If you're running a public sector website or a public sector service and you suddenly get 10x the usage, I guarantee they've not collected 10x the tax to pay for it. And so you need to think about how you build in that scale, not just at the infrastructure level, but at the application level. And as I mentioned, even traditional infrastructure is different in the cloud. So a simple EC2 web server, fixed price per month. Yeah? Not really, because you've got things like data transfer outbound. If somebody uses 10x it, you pay 7, 8 cents per gig. VPC flow logs, the more people access your traffic, the more VPC flow logs are generated. They're stored in CloudWatch logs. They paid money. CloudWatch logs, again, that generates cost. DNS queries, EBS snapshot costs, even if they're fixed. If there's data that's changing on the EBS volume, the snapshots will be bigger each time. And even though some of these can be disabled completely, it's really, really difficult, if not impossible, to fix those costs. So which AWS services are unbounded? Well, pretty much all of them. So anything that charges for data egress, I will put the caveat, I didn't update this slide from the last time I presented this. CloudFront, I think you can now strike a line through it. So yes, they're listening for my last, only another 20 services to go. S3 puts and gets, they are unbounded. They will throttle to prevent AWS issues, but not your bill. Step functions, I learned that the hard way. And then a whole bunch of other stuff is typically AWS will beat you in terms of scale. Some make an effort. Things like DynamoDB, you can have a provision throughput model, which means that you pay for a certain amount of capacity. If you exceed that capacity, you get retry errors. But in general, it's quite difficult. So how do you get around that? Preventative controls. What are these? IAM and SCP policies. People familiar with IAM policies? Hopefully most people. SCPs. So if you're not, these are service control policies. You can think of them as IAM policies applied at an account level by an organization. They are now pretty fully featured. It always used to be they were quite limited in some of the conditions you could set, but now it's pretty much the same syntax and the same capability as a normal IAM policy. And you can be quite specific about things like, I'm not going to allow any volume type other than GP2 and GP3. I'm going to set the volume throughput to be 125. I'm going to set the volume IOPS to be 3,000. Even this policy is really difficult to figure out and manage because they have different variables for different things. So there's lots of edge cases, especially if you're doing things like modifying. So you not only have to avoid things like a create volume IO2, you also have to prevent a modify volume from GP2 to IO2. So there's a whole bunch of conditions you have to put in. But it's worth the investment because these are the things that will block the problem. So again, showing my age with the Men in Black reference, but these are the first, last, and only line of defense are your IAM policies. So best practices. Start with explicit allow for services you know. And by the way, SCPs follow the same principle as IAM policies. So there's an implicit deny. If you don't mention something, it's an implicit deny. If you put an explicit deny, that overrules anything else, it's a deny. To enable a service at an SCP level, you have to have an explicit allow in your service. So you start with an explicit allow for the services you want, which means you have to go through 230 odd services and figure that out. Do that at the OU level, and then that will scope it at that level all the way down. So once you set an allow, that cascades all the way down unless you implement denies. Again, I'm not going to go into the full detail here, but the policy is explicit allow, explicit denies, and then the remaining services are implicitly denied. That gives you some scope later to add them in as allows if you want to add it further down in your OU structure. But if you put an explicit deny at the top, things like, for example, you might want to turn off Shield Advanced, which is something that can cost you a lot of money with difficult. You might want to turn off the big, 6 terabyte memory instances. They tend to run up a bit of a big bill as well. But it's not easy to do. So I did say there's going to be any guesses? What was that? Sorry, nope, not an error log. Yep, close. Not quite a.
Something you don't want to click in the bot mode.
That's the EC2 IAM action space. So that's one service. If you want to be restricting what EC2 can do, you can have 710 actions that you can restrict. How many of those have a cost implication? Any guesses? I have no idea. And I don't think AWS does either, to be honest with you. I had a Google around to see if anyone wants to vibe code an app. Vibe code something that takes the AWS namespace, all the actions, and figure out which ones cost money. And people will pay good money for that service.
Is it a GIF or is it just that it moves when you look at it?
I think it just moves. It's not a GIF. No, that's just the display.
Okay.
Yeah. Trying to get that list, by the way, was really awkward. I had to go to the IAM policy simulator and then look at the JavaScript, because trying to get any of this from AWS is a nightmare. And then you just basically take the JavaScript out, and then it was just reducing the font. However, there is one useful link that I use more than any other thing when I'm working on IAM policies. It's the IAM service authorization reference. This is where they document every single API action, not only the actions, but the resources they apply to, the condition keys, any additional related resources. It's a massive document. Again, second vibe code challenge. Take that website and turn it into an application that is searchable. Some people have tried to do that. It doesn't really work because AWS are rubbish at designing structured documentation that goes all the way down. Again, 2 pizza teams, each service does something slightly different. When they do that thing that's slightly different, it means that even the documentation is slightly different at different levels, but it's a pain. Okay, so service throttling we talked about briefly. A few services let you set throttling or concurrency limits. We talked about Lambda, we talked about DynamoDB. It might be at the account level, so you might have to do it at an account level, you might do it at the resource level. So those can limit the impact, but they will also obviously impact any production stuff as well. What I'd really love for AWS to do is there's a whole bunch of service quotas that you can then now automatically increase by raising a service request. I'd love to be able to go in and turn that down. I don't want to launch 100 EC2 instances in my dev account. 10 will be fine, so let me lower that limit, please. But again, okay, so that's preventative controls. Now we come to responsive controls. And this is where I think we've got the sort of elephant in the room. So I did this graph back in October when I first did this presentation, and I did some analysis on Cost Explorer. And these are the lags. So what I did is basically took something I know was generating a cost, and I looked to see when that cost was represented in the Cost Explorer data by calling the Cost Explorer API. Every time you call the Cost Explorer API, it costs you a cent, by the way. So AWS aren't missing a trick here. Here you can see the random times where there's a dump of data. So here it's 23 hours out of date, drops down to about 11 hours out of date, and so on. The best case is 8 hours behind. Worst case was 25 hours. Average about 16 hours behind. And really no consistency as to when it updates. So you can't assume it's going to be 8 a.m. every day. I remeasured it again a couple of weeks, or about a month ago, in preparation for this one. So this is the 2026 edition. It's got worse. So now the worst case is 31 hours with an average of 17 hours rather than 16. And again, you can see that there's no particular spikes anywhere. So you cannot rely on Cost Explorer for immediate overspend. Anytime you see somebody who posts something on a website and says, oh, you should have just set a cost alert, you can laugh at them and point to this graph, okay? In fact, I actually had an argument with somebody on LinkedIn about this who posted on one of the sites if you follow LinkedIn. I suspect because there's more data. So the amount of data that comes in from... So I don't know if this is true or not, so I'm not divulging sort of AWS state secrets. But again, AWS develops a lot of services internally. I'll come to you in just a sec, yeah. Develops a lot of services internally that they then make available to general use because they find them useful. My understanding was that Kinesis was developed to handle how do you handle billing data, which was in the terabits per second of volume. Yeah, that's to give you some idea of scale. And AWS does operate at that scale all the time. It's incredible. So yes, a question.
Yeah, is there like a reason why it seems to follow this like jagged kind of pattern? Is that the same for most developers? Or?
So this is nothing to do with anything that you can have control of. This is when AWS releases the next batch of the Cost Explorer data. So the question was, is this a developer implementation? No, this is just querying every hour to get that data. Well, I say every hour. I'll come back to that. So Cost Explorer tools. Cost anomaly detection. Great in theory. We'll come back to why it's not so great in practice. But it's designed to spot deviations from daily norms, either as a percentage and or as an absolute amount of spend. And it can use daily report summaries or individual alerts if you're happy to set up SNS and you come back to that end user notification issue. Budget alerts that trigger when budget threshold are met. So you can say, I'm at 80% of my actual, my 80% spend is actually at the limit, or I'm predicted to exceed 100% by the end of the month. But again, all based on that Cost Explorer data that is out of date. And this leads to a quick diversion. So I mentioned about a story where one of the developers screwed up. This is where I screwed up. So I was setting up Cost Explorer monitoring for this. And so what I did was I launched an EC2 instance because I believe in instances rather than serverless. Sorry about that. And I created a cron job on an EC2 T4G Nano. At least I tried to create a cron job. But the last time I did Linux development was about 10 years ago when you could use cron tab. Now you have to use systemd, and it's horrible. And anyone who says otherwise, I will fight out in the car park afterwards. So anyway, I played around with cron tab for ages, couldn't get it to work, followed documentation on systemd, managed to get it working. Great, that logged it every hour. Except I didn't spot that the cron job actually also worked. The cron tab also actually worked and was capturing it every minute. Remember, I said it's 1 cent for every Cost Explorer request you get. So now I'm getting 60 cents per hour from that one, plus the one from the Cost Explorer that's running every hourly. So now my little experiment that I thought was going to cost about $3 has gone slightly higher than that. That's my cost and usage graph from my account that I was only doing this in. The blue line is the Cost Explorer bit. Yeah, not great. Thank you, anomaly detection, because hey, I've never had that spend before. You look at my graph over the last 6 months, there's never been that anywhere. So anomaly detection, right? No. Nothing. To this day, there is nothing that's come up on my anomaly detection for that overrun, which was, what's that? 2 orders of magnitude, 3 orders of magnitude higher than it would normally be? Nothing. So I just generally, do not trust, and I think you cannot rely on anomaly detection. It doesn't spot genuine anomalies that are there, and it seems to then flag on a whole bunch of stuff, and this is where it generates a lot of noise. If you don't configure it properly, it generates a lot of noise. And even if you do configure it properly and it triggers something, it then continues to trigger it. So I've got an alert at the moment. A customer has launched a G4 instance because they're doing some experimentation. They launched that 3 weeks ago. I still get daily notifications that there's an anomaly, even though that anomaly is exactly the same amount per day for the last 2 weeks. I don't know when it's going to stop. At this stage, I'm hoping the customer keeps that going for ages because I want to know. But it's just not responsive enough because not only does it rely on that Cost Explorer lag, or take that Cost Explorer lag, it also has to work out what your normal looks like, which is typically over a 10-day historical period. So by the way, if you also enable cost anomaly detection on a new service, you have to be running that service for 10 days before cost anomaly will work. So if you think it's going to catch you experimenting with a new service, think again. Okay, So back to the story. What can you do about it? So CloudWatch Metrics to the rescue. And again, this service is quite maligned. Lots of people probably use things like Datadog or Grafana and Prometheus, whatever it might be. CloudWatch Metrics is actually pretty good, and it's getting better all the time. It's one of the teams that is actively developing. Their data is typically less than 5 minutes old. And what you can do for most services, you can look for metrics that capture absolute overall service usage. And then you can enable anomaly detection on that CloudWatch metric data, which does work, and it will even give you error bars so you can see when stuff's fluctuating within, and you can trigger alerts from that. Yep. And then what you can do is actually, if you know what service caps are and what your expected spend is, you can then work backwards from that to create effectively a budget alarm that's real time. So let's take an example that was the step function. So it costs 2.5 cents per 1,000 state transitions. So let's say I don't think I should be spending more than $10 per month on step functions. So when you work it out, that $10 is about 400,000 transitions per month. So if I divide that by the number of minutes in a month, that gives me about roughly 9 transactions per minute is what it would take to trigger $10 of spend. So what I do, I create a CloudWatch alarm that triggers if we exceed 9 transactions per minute for 2 out of 3 periods. If I'd have done that, so again, this is the data that I consumed. If I'd put that alert on, I would have been alerted about 5 minutes into that issue. And I could have gone and had a look. I would have seen the metrics gone way up, and I could have blocked it. Again, opportunity for people to vibe code this, I think is awesome. These are sort of real-time budgets that I think you can get that you can't get anywhere else. Not every metric or not every service emits service level metrics. But what you can do is there's a great service called CloudWatch Metrics Insights, which allows you to aggregate multiple metrics, do some sums on them, do some maths on them, and then monitor that. So in this case, what you can do, for example, NAT Gateway, everyone's favorite topic to hate, you can aggregate all of your NAT Gateway, all of your bytes out data into a single value, work out what you want the limit to be, and set an alarm when your threshold exceeds that. And so now you will get alerts when lots of people is going out through NAT Gateway, which probably means you've misconfigured an S3 bucket, or your S3 bucket's being talked through a NAT Gateway to a public endpoint rather than a gateway endpoint. Okay. So then we come to analysis tools. So all this has happened. What can we do to sort of fix it? So Cost Explorer. Hourly granularity, we talked about this. So I'll go through this fairly quickly as we've done this. What I would say is there's an option to enable hourly data for the last 2 weeks. It's a paid feature, but enable it anyway. It gives you an estimate of how much it costs. I've enabled it across something like 17 accounts in an organization. It's costing me about $2 per month. And it means that I can go into CloudWatch and I can see hourly spend per service. The other thing to do is, how many people here use AWS credits? Yeah, I guess a few people do. Do you exclude them when you're doing Cost Explorer reports? Because if not, your Cost Explorer graph is blank, because it's working out the charge minus the credit. So if you want to see if your service is barreling along and spending too much, then you need to exclude the credits, which you can do from a filter down at the bottom right. Otherwise, at that stage, you're going to be seeing 0 until the credits run out, and then it's going to spike. And by the way, when I mentioned about AWS doing sort of providing a refund on the bill if you screw up, they don't refund credits. So trend reporting you can also enable. Again, great, but with the Cost Explorer lag. This is one I only found recently, and I'm ashamed I only found it recently. Cost Explorer dashboards. Anyone come across this? Good. You're better than I am on that one. They're amazing. You can create basically multiple Cost Explorer reports, put them on a single dashboard. What's even better is you can create that once centrally, share it to the rest of the organization, and they will pick up that report, but only with the data they're allowed to see. So I've now got a report that anyone in my organization can use on an AWS account, and they will see just their data in their account, but using all the metrics I've set up. And so you can see sort of hourly spend, daily spend, monthly spend. You can start spotting trends and so on. And that's just a bigger view of that dashboard. So again, here, if I suddenly get a spike, I can start seeing what happened here. Oh, yep, here, what happened there? Cost Explorer.
And I think it's worth mentioning that it actually works pretty well with the Q developer in the console as well.
Hold that thought. And if you want to go, so if anyone, just repeating for the purposes of the camera, it works well with Q developer in the console as well. Yeah, hold that thought. AWS recognizes the fact it's a challenge, and so they produce something called cloud intelligence dashboards. It's a really complicated solution that produces some really interesting information. It costs about $200 a month to run. But if you've got a big organization, it's a good way of providing a whole bunch of metrics you couldn't normally see. And if you want to go there, that's the QR code. Again, this video will be up online in a couple of days, so you can get the QR codes from there. So remember what I said about AI. Okay, Kiro. So not quite Q Developer, but I'm using Kiro CLI with a Q Developer license. In my mind, if you have to choose between buying a Q Developer license and a Kiro license, buy a Q Developer license, because you can use that in the console on the side. You can also use it with Kiro CLI just by authenticating against that. If you buy the Kiro CLI, you only get access to the Kiro CLI. You can't use it in Q Developer. Anyway, I thought I'd give it a little test. So I asked the question, look at my Cost Explorer logs for the last 5 days and identify anomalies or unusual cost patterns. Make sure you exclude credits from the analysis. Do this specifically from my Sandbox account. Use the AWS profile that gives read-only access to that account. So I did that. It failed. But it figured that it failed, and it tried again without me prompting. So it recognized it had the wrong syntax. And then it does blah, 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 blah. Finds that. Here's the analysis. So again, I hadn't prompted it anymore. Anomalies identified. Cost Explorer, massive spike from $0 to $14 per day. Biggest red flag. So identified the jump. It called out the API call that cost it, how much it costs. It worked out roughly how much it used per day. Recommendation, look for step functions or something that was scheduled. It noticed some EC2 compute that I turned on as well. Forget about that. So I said, right, using the profile, try and find what the source was. Didn't give it any other prompting than that. So it recognized it needed to go to CloudTrail logs to look at API requests over the last 90 days. It came up with a query that it ran. And then it came up with this. The CloudTrail data is crystal clear. Here's the smoking gun. EC2 instance running a Python script every minute. It identified the instance. It identified the rule that was attached. It identified the user agent, the version of Python I was running. It worked out the frequency. It was called out down to the second. It recognized it was being called with hourly granularity. So it's a Python script, an EC2 instance every single minute that works out to the cost. The one thing it didn't identify is the extra 24 cents was the one that's running every hour that was intended to. But I'll let it off that one. The query time is running every identical, so it's obviously something that's going wrong. Recommendation, turn it off, fix it, and so on. Yep, I'd already turned it off by that stage. So I said, well, tell me more about the instance. So it then went away, gave me the instance, told me what it was, told me which VPC it was in, told me the name, even worked out the name CE monitor. So it figured out it was explicitly set up to do this. Told me when it started, when it stopped. It then said, do you want me to go and fix it for you? At that stage, no, I'm good. I'm good. So maybe AI is a thing after all in the right use cases. Anyway, key takeaways. As hopefully I've said, things can go wrong in lots of ways. Serverless, infinite loops, unbounded scale, not really serverless. In some cases, you scales to 0, but you still pay a cost. Storage is a key one. IOPS is one, especially a developer who doesn't know and they're coming from on-prem. Yeah, I'll have an EC2 instance with 60,000 IOPS, please. Okay, start paying $50 a day for it. You probably don't need it. And then obviously leaked IAM credentials is the worst possible thing you can have. Prevention is definitely the best cure. Do the basics. Everyone hates SCPs. Everyone hates IAM policies. Book some time in your diary before the end of the week and go and look at them and see how bad they are and how you can fix them. Disable regions you don't need. Control Tower makes that quite easily. There's a bunch of controls you can put in there, organizations to do that as well. Turn off the stuff you don't need. That's an entire surface area reduced. Responsive controls, do the basics, create a budget. Even if the budget isn't going to capture everything, you'll start seeing trends that go upwards. So it's not going to capture the big anomalous spike, but it's going to capture those trends. Create the CloudWatch metrics for the alarms. If you've got developers and they're working on a new service, think about implementing a CloudWatch metrics for it. And when you do, save it and use it for the next account and the next account. So invest time in that alerting. And then lastly, insights are key. Have that information available, have those dashboards available, and be aware of cost-conscious design. Everyone here who's an architect is also a FinOps practitioner. And that's it. I'm probably massively over time. But any questions? Yes?
That's me.
Yes. Yeah.
Yeah, so thank you very very much for the talk. Very interesting. And you mentioned that you had to fight off a DDoS attack back in 2012. How did you capture that correctly?
Yes, 2012.
Did the lessons you've taken include something like what you have set up here with the CloudWatch to detect anomalies as they're happening rather than following the cost and all the reactive controls?
Almost, but the attack was an on-prem attack. So we actually used AWS as an in-cloud proxy layer. So all the metrics we had were on-prem using VMware and stuff like that. But yeah, definitely those metrics, looking for spikes, looking for anomalies is definitely something that's worth doing.
It is worth it, but did it actually translate into what you should have done that you have realized that you should have done already?
Possibly, yeah. So I think I'm always learning. So that Cost Explorer mistake, that again is something about maybe track for new services and think about how that. Also, maybe set up a recurring job that runs an AI query at the same time every time. So just a couple more questions because I'm really conscious of the other speakers.
Your problem was step functions. Are you able in your application or your company to do that in a batch, like send the request in a batch?
So the question was, could we have batched the step functions? We could have done. I think this was just a new user was experimenting, was looking just to send a manual invocation of that through. It failed. They didn't think anything of it. They shut the laptop down, went off for the rest of the day working on something else. But because they'd had that recursive loop setting in there, it spiraled out of control. Okay. I will be around afterwards, so if you want any questions, but let's give some time for the next speaker. So, cool. Thank you.